Good morning, San Diego. How are y'all doing this morning? Y'all having a good KubeCon? Come on, great KubeCon. So I have to say, this is the first time I have ever come to stage accompanied by a rack of servers and a Faraday cage. But this is going to be an exciting demo that we're doing here today. So I have spent the majority of my 21-year career in the telecommunications industry. And that has been not only because of its rich history of innovation, including things like the transistor, the semiconductor, the discovery of cosmic background radiation, the creation of Unix, the creation of the C programming language, but also because fundamentally network is the key and foundation of all of the connected applications and services that we use today. No network, no obsessively checking your Facebook 20 times a day. No network, no Netflix and chill. So the network is fundamental, and working on the network is a really extraordinary and amazing thing to be doing with one's career. So within telecommunications, we have been on what we call an NFV journey for quite a while. Back in the day, telecom networks were deployed using custom-built sort of devices. These were custom operating system, custom silicon. They were vertically integrated, purpose-built, generally did only one or two sort of functions in the network. Over time, we began sort of moving towards more and more kind of general purpose compute, general purpose operating system. And then in about 2014, a white paper was published by a standards organization called ETSI, talking about something called NFV, or Network Functions Virtualization. Y'all call it cloud. One thing to know about telecom industry is if we can turn something into an acronym, we will do so. So NFV had the idea that these network functions, all these devices that we deploy around in places like central offices, telephone poles, and radio towers could actually be deployed as cloud applications. And so we started moving that way using VMs and OpenStack, and then started thinking about how we might do that in a cloud-native fashion. So as we think about doing cloud-native, we had this idea, let's actually build a prototype 5G network that is completely cloud-native, built with open source components, and then let's demo it live in front of 12,000 of our closest friends. This may have been a harebrained scheme. So who is this we that I am talking about? We are LF Networking. Like CNCF, we are an umbrella foundation of open source projects underneath the auspices of the Linux Foundation. We work on things from high-speed data planes to service orchestration and integration with the telecom back office, systems integration, automated testing, CI/CD for telecom networks, compliance verification, software-defined networking, big data applications for telecom, open source network operating systems for switches, and the ability to do large-scale network monitoring. Our operator members represent 70% of the global subscriber base. And so our very first project in the networking space was Open Daylight, and I think that it started about 7 years ago. So in telecom, we've actually been on this open source journey for a while. So we also work with other open source and standardization organizations. We work with a lot more than are on this slide, but these are the ones most relevant to what we're showing you today. Obviously, CNCF, this is a cloud-native demo, so we work with them. The Open Air interface is an open source project that has been working on radio and mobile technologies in an open source fashion for several years. The ORAN Alliance is a new project in the Linux Foundation. It is both a standardization effort as well as an open source project, also working on radio and 5G mobile networking. And then the GSMA is the largest association of mobile operators. They put on Mobile World Congress every year, if you're familiar with that event. And we actually created a partnership with them earlier this year, where between OPNFV and GSMA, we have created a joint task force called CNTT, another acronym. And we're working on defining reference architectures for cloud deployments and cloud infrastructure in service providers. So, what is 5G? Besides a buzzword that is in every single article you read in telecom these days. Simply put, it is the next generation of cellular technology. We have gone through multiple generations. When I started using cell phones, it was actually probably 2G. And then we had 3G. Most folks are on LTE right now. 5G is the next iteration. It is characterized by extremely high bandwidth, extremely low latency, extremely high density of devices that can connect. What that means is that there is a great deal of scale needed to do this. To have the high bandwidth and the low latency, we need to move the radio out a lot closer to the end devices. And so that presents some challenges. But essentially, this is going to be the network that is available to mobile operators in the future. We're expected to have 50 5G commercial networks across 27 countries, and the global market is expected to reach just under 700 billion by the year 2026. So it is massive in terms of scale and massive in terms of economic impact. But don't take my word for it. Let's hear from the largest mobile operator on the planet, China Mobile. So I'd like to invite to stage Fu Qiao, who's a technical lead at China Mobile. Fu Qiao, come on up.
Thank you, Heather. Thank you. So good morning. I'm Fu Qiao from China Mobile. So I'm here to bring the use case of 5G in China Mobile. Talking about 5G, we actually begin our commercial service of 5G in 50 cities in October the 31st in China. So from our perspective, what see 5G is not only just the next generation of telecom technology, but we see that as somehow the innovation and transformation actually for all the telco technologies. First, we are expecting it, of course, as a basic infrastructure to support services, not only telco services, but also edge computing services and other third-party services. And secondly, we're also thinking that 5G could enable other fancy technologies, including big data, edge computing, artificial intelligence, because of the benefits it could bring with low latency and high bandwidth. And thirdly is about 5G will be a healthy ecosystem, which will provide the sustainable growth of the creation of new 5G applications. With all of these, we're thinking that 5G could possibly bring innovation and transformation for other industries, including healthcare, education, and smart cities, for example. So how does the 5G network actually look like in China Mobile? We're actually working on that like a core-to-edge structure, where we have most of the control plane services located in the core. We are now actually building 8 core clouds across the country in 8 different provinces in China. And then we will bring up hundreds of edge clouds across the country distributed with all those user plane services. We have 5 expectations of our 5G cloud. First is about the resource. We're expecting that the resource could be globally scheduled so that we could actually move our services across the cloud. And second is about the capacity. Second is about the capacity, which means that we will expect the capacity could move, scale in and scale out with the requirements from the services, actually. And third is about the structure. We're expecting that the structure of the 5G cloud could flexibly tuned. For example, when you move to the core, the structure could be a little bit complicated, taking consideration of the redundancy, shared storage, for example. But when you go to edge, you have to be better trimmed the structure so that it could fit into the limited space and power of the edge spot. The fourth one is about the deployment of the services, where we are expecting to pull up new services within minutes, or rather than within days, weeks, or even months. And last thing is about platform as service. We expect that to be fully open and could share with the services with common APIs and capabilities. So while we're actually building this 5G cloud, there are 3 major challenges we are actually now facing. First is about the infrastructure. We say that it's still insufficiently decoupled. Comparing with some of the bulky hardware in the past, we're still bonded with some software silos from a single vendors. And that could really give us some trouble when we actually want to share the global resources of the cloud. So we're expecting that infrastructure could evolve from the VNF bounded to actually white box with the APIs and capability defined by some community-driven efforts. Second is about the service, which is still insufficient service-based architecture because we're still lacking of common services at the platform level. So instead of building some of the services in just a single VNFs, we're expecting to break it up to cloud-native components. And last one is about the operation capability. It's funny to say, actually, but operation is actually now a quite big obstacle for telco operators. Comparing with the increase of complexity of the network, we're still lacking of sufficient ways to do the operation. So now we are thinking that we could evolve the operation to not only software-defined, but also intelligent-defined, utilizing the technology, including automation and artificial intelligence. So with that, I will get back to Heather to explain more about the demo and how we actually address these expectations and major challenges.
Thank you, Qiao.
Thank you.
So as Fu Chao was sort of speaking toward at the end of her part of the presentation, there are some challenges that operators are dealing with as they're considering 5G. So the question is, can cloud native technologies help address some of those issues? And our presumption is yes. Sort of talking about, I talked about the massive scale that we need to do, and certainly Kubernetes and cloud native is really great at scaling. It's very great at flexibility as we want to do more interesting and sophisticated things with our network and roll out really interesting network services. The performance we think is great, and sort of utilizing sort of we've been doing some benchmarking of performance with the CNF testbed and see a great deal of performance improvement, as well as sort of the resilience. If you think about the network, this is what the 911 system depends on. This is what goes into communication amongst flight towers. The network really impacts sometimes physical health and safety. So we really have strong requirements for uptime and resilience. And fundamentally, having a common infrastructure for applications and the network, utilizing some of the lifecycle management makes things a lot easier. And then the last point is that we really want to be able to work in partnership with the large ecosystem of developers that are building cloud-native applications. It gives us a lot more access to a lot more technical folks who are going to come up with the really interesting, innovative services that are going to go onto this next generation network. And so with that, I would like to actually start digging into the details of the demo. So I would like to invite Azhar Sayeed, Chief Architect at Red Hat, who is one of the developers who's been helping us build this demo. Azhar.
Thank you, Heather. Good morning, San Diego. So as Heather stated, we actually took on a very ambitious project in order to build everything in containers and build an entire 5G network, from the radio to the core components. And we started off this project with partnership from different vendors as well as open source communities. And first it was OAI who signed up and said, okay, let's build this as a live network in France. So that's what you see as a Eurocom facility in Sophie Antipolis in France, where they actually have live radio deployment and a core deployment. Then we built a POP in Montreal with the help of one of our partners, Lenovo, to actually build the entire infrastructure and run a core over there. And with that, we said, well, how interesting would it be if we were to actually bring an entire POP right on the stage here with us that is remotely connected to the core in Montreal. So that's what you see here at the back with these noisy fans is the full edge POP with some servers that do edge compute, that do the radio capability with a Faraday cage that was custom built just for this particular demo, and a 5G radio in there. So I'll walk you through those in a moment. Let's go look a little bit deeper into what each one of these setups are. So the first one is the San Diego POP. And what you see in the San Diego POP is essentially a 5G phone that's connected to two different radios, the LTE radio as well as the 5G radio. And then you have a piece of software that's running on a whole bunch of servers that you see in that POP. That software is essentially the radio software, CU and DU. That software is also a firewall that's all running in containers. It's also an SD-WAN gateway. The firewall is from our partner A10, and the SD-WAN gateway is from our partner Turnium. And we have actually an interesting software-defined fabric that's also part of this same setup. And I'll just walk you through very quickly in a moment. Let's now go to Montreal, what the setup in Montreal is. Well, in Montreal, we have a full data center setup. It's, again, Lenovo servers, the ThinkSystems SR630 and 650, as well as a number of container network functions from A10, from Turnium, from Altran, from Kaloom, which runs actually a UPF, and Kaloom also runs the software-defined fabric both here and in Montreal. And the Lenovo Open Cloud software that is actually used for managing the entire system from a hardware perspective. So that's also running in Montreal. Now let's take a quick look at what's happening in France. Well, in France, we have another independent network with radio, with the packet core running on a rack of servers with a fabric that's running by Cumulus. Again, we have a whole bunch of container network functions there with A10 NAT and firewall, Turnium SD-WAN gateway, open air interface software, that is the radio software as well as the packet core software. And of course, there we were able to get the 4G setup going in containers. So we have actually a 4G radio and a 4G phone that's set up over there. Now, a lot of people ask questions about, okay, so what was the full software stack? Can you actually show what that software stack looked like? Well, one of the interesting things we ran into was the number of community projects that were involved in this setup, as well as the amount of software that came from all of our partners and different vendors. So if you take a look at the left-hand side of that slide, all of those different community projects and products were involved in this particular setup. On a private cloud environment, both on OpenStack as well as on bare metal, we are running, of course, Linux software from Red Hat, and we're running the Kubernetes platform OpenShift from there, and then a whole bunch of container network functions or CNFs. In the public cloud environment, we are running, again, Linux, which is CentOS. We're running Kubernetes based on one of our partners called Ludza that actually provides provisioning of these Kubernetes environments called Kubermatic. And then again, a number of CNF functions from various different partners. Of course, Intel is also providing a whole bunch of software, Altran, Ludza, so many partners to be involved in this. Now let's take a look at a quick animation of how things work first, and then we'll actually show you all the screens, and we'll actually show you hopefully a live call. Again, we've been having a number of challenges associated with this because we are trying to connect private cloud, public cloud, remote POP, all together over the internet with a whole bunch of tunnels, and I'm crossing my fingers, hopefully everything's gonna work. So let's take first. So what happens first is the two phones, the first phone here, that's on the stage here that you can see. I'm just gonna quickly walk you through. Here's your rack. That's the fabric that you see inside that's with blue lights, software-defined fabric. Here's the millimeter wave radio, the 5G radio, and that's the Faraday cage, and that's the phone inside there that's actually 5G. So first, when we power on the phone.
Why is the phone in a Faraday cage, Azhar?
We couldn't radiate the frequency. This was millimeter wave. We had to actually show a live demo. We couldn't just hack it or show Wi-Fi or something else. So it was literally a custom-built Faraday cage. We sat in one of our colleagues' living room and built that over several couple of days. And I really, a lot of credit to my friend here, Pasi, for actually doing all the work that he did.
Yeah. So essentially, if we were radiating out 5G frequency, not being licensed mobile operators, we would be in violation of federal law.
Absolutely.
That's why it's in a Faraday cage.
Absolutely. So the two phones register. So that phone registers to the 5G core and the LTE core that's actually sitting in Montreal. So it's actually from here, going through that radio, going through that POP, and all the way into Montreal. So that's what you see by the yellow line. The other phone that's in France is registered to its local core right there. Now, obviously, since there are two different mobile networks here, and we don't have any roaming capability. We don't have any network-to-network connectivity like that. So we had to actually figure out a way to show you a live call across those two networks. So we actually decided to host an IMS capability in the public cloud. And what you see in the public cloud there is the IMS core right in the middle. And once these phones attach and have data connectivity, they connect to the IMS core, and they actually exchange information, they do the IMS signaling, and say, okay, now I can actually do an IMS call all the way across. So when that happens, now you can have actually a call all the way across. Obviously, we've been having some connectivity challenges, so we'll try to attempt a live call right here in front of you. We also have some other people on standby in Montreal and locally, so we'll show you whatever that's possible. So back, please. Let's now go to the screens.
Yep, so now we'll move over to the live demo and pull up stuff here live on the laptop.
Okay, so what you see here first is the dashboards. This is the OpenShift dashboard of the container Red Hat OpenShift container platform. And what you see here is the dashboard coming in from the Montreal POP. And you can see about 278 pods that are running in that Montreal POP. You can see there are 8 nodes there. There are 16 persistent volume claims. You can actually go into workloads and look at the pod details, and you'll see all these pods. Now, one interesting thing that I wanted to show you was the project that we are seeing here is the Altran 5G core project. Within the Altran 5G core project, these are all the different containers that are running as part of the Altran 5G core in the Montreal POP. We also happen to have in the Montreal POP a LTE core, so I'll just show you that as well. So Altran EPC, and you can see that there are a whole bunch of pods that are running as part of the Altran EPC in that in the Montreal POP. Now, what I'm going to do is also just show you very quickly this setup here, the 5G POP here, and the number of containers that are running here. About 215 containers or 215 pods on this setup. And you can also see different workloads here. This is default. Let me just go check here you go. This is the A10 setup. And I can scroll through any of those different projects to show you the different pods that are running there. So this is all live. Now, Kubernetes also provides the a monitoring capability as part of open source. We can actually go take a look at the cluster here, and we can actually take a look at the different workloads that are running. And this is all live from the different pods. But what's interesting and important is to actually get all of the different stats. And in OPNFV, Heather, you remember working through the Barometer project with a number of our partners. And we originally started that for OpenStack. Now we're applying the same project, same monitoring capabilities, common setup across private cloud, public cloud, and the POP here. And you can see the stats here right on the screen. Now I can choose any node. Interestingly, I only have one monitoring setup that also is looking at the Montreal POP and the local nodes. So the nodes that you see here right on top, 1, 2, 3, 4, 5, are from Montreal, and you can see these stats change. And the nodes that I'll show you locally is this one right here. So when I say worker 1, that is this node right here. Worker 0, it's in that particular 5G POP setup. And when I move to VCO worker, that's part of the Montreal setup. So you can actually see a whole lot of statistics around memory usage, network utilization, network traffic, memory distribution, loads, disk space, and on and on and on. So that's interesting. Now what I'm going to do is quickly show you first on this phone, if they can zoom in onto the phone, please. I want to go back. Right here, you can see right on top something that says 5G UWB. It doesn't say LTE, it doesn't say 4G, it doesn't say Wi-Fi is on, it says 5G UWB. That stands for 5G ultra-wide broadband. So that's to show that that phone in that cage is actually attached to the 5G network. Now what we're going to try to do is attempt to make let's get one of our friends. Before we go to the call, let's go to we have a Twitter feed on the phone. What I want all of you to do, and this is probably one of those first keynotes where everybody says, shut off your phone. I'm going to say, pull out your phone, tweet, with a hashtag called 5G Cloud Native. And hopefully by the end of this, I would be able to show you your tweets live on that particular 5G phone. So if you can, please tweet 5G Cloud Native hashtag. And let's now go back, while that tweet is happening, let's now go back and try to attempt to make a call. So can we get the remote team to call in, please? Okay, we have someone calling in. Let's accept. Call in, okay.
Are we dialing?
Yeah, we're dialing.
All right, cross your fingers, everyone. We are up here without a net doing a 5G call over a prototype cloud-native network.
All right, there you go. There's a call that came in. Let me just accept that call. I got the call accepted. Let's start the video feed. Yay, so that video you can see is coming from the Faraday cage, and we have, hello, how are you?
Hello, Hanan.
I hope you can hear us. And that's a live video feed over there.
All right, so everybody wave hi to Hanan, say hello to him.
Thank you so much.
Can you hear us now?
Excellent, we can hear something back. We can hear some audio back. All right. Okay, thank you so much, Hanan. That was wonderful.
All right, bye, Hanan. Adios.
All right, so we'll come back to the tweet in a moment.
All right, so just let's pause for a moment. You know, it didn't look amazingly beautiful, but that was a live 5G call connecting across public and private clouds, connecting to a packet core in Montreal, an IMS core in the public cloud, and an LTE lab in France. So good job, Hanan.
Good job.
Yes, I have been so nervous thinking about that phone call for weeks and months now.
So what we have from one of our partners, NetScout, is actually an interesting monitoring application that does correlation. So what we showed you earlier was node monitoring capability, traffic monitoring capability. Now this particular application from NetScout actually shows you a correlation. So it can actually show you things like SIP calls that are going through and attach to those different S1U interfaces on the mobile side to actually show you what's exactly going on. And you have various different dashboards here as well that can give you a pretty detailed information. And oh, by the way, all of this is completely live on all those three different setups that you saw earlier on. So
okay, let's go check our Twitter feed.
Yeah, let's go check our Twitter feed for a moment.
No network, no obsessively checking your Twitter. No network, no obsessively checking your Instagram feed. So
okay, so you see there was a new Twitter with you speaking right there. That just got updated. Here's another one that somebody just, I'm sorry, this is way too fast for me to scroll. Here's another tweet that just came in. So
it's working live. We did not make this up. We did not pretend with smoke and mirrors. This is not a canned demo. This was live. You can actually see your traffic going over the network. So,
absolutely.
So thank you, Azhar.
Thank you.
Now let's go back to our slides.
Yeah. So, lessons learned.
All right, so as we were building this, we did learn some lessons and we did find some gaps. Azhar, do you want to talk about some of those technical gaps?
Sure. I mean, we've learned a lot of lessons. It was really a lot of hard work by a very large team, and I'm actually literally just representing them here. Some of the biggest lessons learned primarily for this community, for Kubernetes communities, networking. We have to solve a whole bunch of networking problems with Kubernetes still. We use Multus, we use secondary interfaces. The visibility of secondary interfaces isn't there. We didn't have custom resource controllers for those secondary interfaces. So it was a challenge trying to understand how things work, default routes, ETH0 versus secondary, and actually managing that whole capability. Because telecom infrastructure is all about networking. It's all about connecting those different parts together. It's all about connecting those different services together. That was one of the biggest challenges.
Okay.
The second biggest challenge was overall maturity, right? We don't have common descriptors for different network functions. we don't have common ways. Everybody has their own description file. And once you start to onboard them, everybody has a different expectation from the infrastructure. So the infrastructure really needs to evolve to be able to meet some of those capabilities. And we need some level of commonality. And perhaps the initiative that you have with GSMA in CNTT will help in terms of coming to a common agreement in how we actually build this type of infrastructure. Then, of course, there were a number of other challenges associated in the area of 5G space with radios, with frequencies, with getting the right kind of equipment, and hardening of that particular code for stability. But all those things, I'm sure we can talk about it offline. We don't need to spend more time here. But from a community perspective, I think it's a great opportunity for us to A, start in this environment, B, learn from these experiences, and C, build upon them to create some sort of an industry initiative I'm sure you're going to talk about.
All right,
So,
cool.
thank
Thanks,
you very
Azhar. Let's give Azhar another round of applause. All right, so Azhar mentioned a couple of the challenges. So we really want to work in partnership with the cloud native community to solve some of the networking challenges. Also within the LF networking projects, we have a lot of initiatives going on around this, around cloud native reference architectures. That goes back to that partnership I mentioned with GSMA around CNTT. We recently kicked off an initiative around CNF compliance and validation testing. We've got things going on in ONAP to be able to support the provisioning of cloud-native network services. FIDO VPP, I know that we've heard a lot about that. That becomes very important for our high-performant networks, and they are doing some work on supporting the 5G user plane. And then we also are obviously working closely with the telecom user group here. If you want to get involved in any of these initiatives, I hope I might have inspired you to want to get involved in some of these things. Here are some links for places to get started and to learn more. We also have a developer event coming up in Prague in January. It is free to attend. We'd love to encourage any developers who want to work on this in the future. While you're here at the show, here's some more places you can learn more, whether that's on the booths. We've got some breakout sessions, and there is a suite at the Westin where you can sort of meet with some of the developers who put this together. And now, Azhar and Fuchao, if you want to come back up, I want to take a moment to thank the partners who helped us do this. We had more than 15 companies participating and pulling this together. And most importantly, more than 80 community volunteer developers who did all of the hard work of pulling together these resources. And I'd like to stand up and have you stand up and be recognized. So. And what this really points out, honestly, is the power of open source, right? Bringing together people from 15 organizations, from 3 continents, multiple countries, multiple companies, multiple open source organization technologies. We were able to come together and build a prototype 5G network that is fully cloud native and actually demonstrate it. You can't do this in a silo. You can't do this on your own. This is the power of open source. So I encourage all of you, for the rest of the time that you're here, get out of your silos, go talk to people who work on other projects, talk to people who work at other companies, talk to someone who's not from a place where you are from, and get to know people, build community. Because we are open source, we dream big, we build amazing stuff, and most importantly, we do it together.